Okay, let's start with number one. Number one says find the sum. Start off by plugging in 1. So replace all the i's with 1. Pull that up. Then plus. Then insert 2 in for i's. Plus. And then insert 3 in for I. 3 will be the final I value that you insert in, because that's the upper bound here. Okay, any questions with 1? Okay, number 2. Use sigma notation to write the sum. We start off by creating our summation notation. Oh, sorry, thanks. So we start off by identifying the parts that are unchanging. So you see the 7s are all unchanging, the square root's unchanging, but the number inside is are changing. Leave that alone for now, because we know I will have to be involved there for that change. Okay, now before I commit to an I value, normally I'll say I equals 1, which is possible, but maybe there's an easier I value here, because we're starting at 3, 4, 5, and 6, and 27. 27 is what?
3 cubed.
3 cubed, 4 cubed, 5 cubed, 6 cubed. So we could start at 1, but maybe it's easier to let I start at what?
3.
3, yeah. I mean, start at 1, that means we still have to, we got to do a little bit of adjustments with the I value to force it into a 3. So I would say a lot of times you start at 1, but if you, sometimes it's easier if you realize that there's an easier number to start with. So what can we put in here for the square root? Just I, right? So 3, 4, 5, 6. And what can we put in the denominator?
I cubed.
I cubed, right? I cubed, 4 cubed, 5 cubed, yep. And what's the final I value we're going to insert into the rule? 6. Okay, let's look at number 3. 3 says use 4 middle rectangles to approximate the area of the region bounded by f of x between 1 and 7. So let's start off by building our width. My a value is 1, b value is 7, my n value is 4. Sorry. Okay, let's build out our bounds and our subintervals here. So we're starting at 1. We're going to keep adding 3 halves to get to our next subinterval point. So 1 plus 3 halves. It's 2 over 2 plus 3 over 2. 5 over 2. Okay. 5 over 2 plus 3 over 2.
7.
8 over 2,
Yeah,
right?
yeah.
Which is the same thing as 4. 8 over 2 plus 3 over 2.
11 over 2.
11 over 2 plus 3 over 2. 14 over
2.
2, which is 7. Now we could stop here if we wanted, if they're asking for left or right rectangles, right? Because we can just find the left or right endpoint, insert into the function to get the heights. But this one is asking for middle rectangles. So we got to take the additional step and find the midpoint. So to find the midpoint, what do we do?
Add together, divide them by 2.
Add together, divide by 2. Or if you don't do it by hand, add together and multiply by 1/2. That's the same thing. So if I do it by hand here, half of 1 plus 5 halves. So that's 2 over 2 plus 5 over 2. 7 over 2. 7 over 2 times 1/2. 7 over 4. You can also use your calculator as well. Okay. 5 halves plus 8 halves is 13 halves. 13 halves times 1/2 is 13 fourths. 8 over 2 plus 11 over 2 is 19 over 2. 19 over 2 times 1/2 is 19 over 4. 11 over 2 plus 14 over 2. 25 over 2 times 1/2 is 25 over 4. So we're going to use these midpoints to attach to the function to get the heights, and then we'll plug into the function to get those actual height values. So the area made up of 4 rectangles. The width of each rectangle is 7 fourths. So I'll do 7 fourths times. What's the function notation to represent the height of my first rectangle? I'm sorry, my bad. 3 halves, not 7 fourths. My width is 3 halves. Okay. 3 halves times what represents the height of my first rectangle.
F of 7/4.
Okay. Okay, we just go down the line. 3/2 times f of 13/4. 3/2 times f of 19/4. 3/2 times f of 25/4. If you can get to this point, then the rest may be a little tedious, but it's not hard. You're just inserting these fractional values in for the x of the function, getting the result, taking that height value, multiply it by the width, and you just go down the line. You just go width times height, 4 times. Yeah, any questions with number 3? Okay, number 4 says use 4. Let's see, there's 3 parts here. Use 3 middle rectangles with intervals indicated by the table. So first, we want to go from 1 to 15. So 1 to 15. Start in the middle of your first order pair here. So from 1 to 6 can be a 1 interval, and then pick up where you left off. Make sure every subinterval shares the previous where the previous left off. So from 6 to 11, and then from 11 to 15. Right? The width is going to come from your first row. The height will come from the second row. Subtract your endpoints to get the width. So width of my first rectangle is 5. Second rectangle, 11 minus 6 is 5. The width, 15 minus 11 is 4. All right, middle rectangle. So I need to pull the height from the second row. So this is my left, this is my middle, this is my right for my first interval. I want to pick my middle one. So 5 times 2 will be the area of my first rectangle. 5 times 3, area of my second rectangle. 4 times 6, area of my third rectangle. Okay, part B, use 3 right-handed rectangles, but careful that you're paying attention to your endpoints, because we're not going from one end to the other. We're starting at 5 and ending at 11. So starting at 5 and ending at 11, we'll do 5 to 6, 6 to 8, and 8 to 11. So subtract the numbers in the first row. That will get you your width. And then first rectangle, I want to use the height of 7. Second rectangle will be a height of 3. Third rectangle will be a height of 1, because I'm doing right-handed rectangles. So every subinterval, I'm pulling the y value on the right. Okay. Part C, use 4 trapezoids. So make sure you memorize your trapezoid area. Or you can think of it as 1/2 width, height 1 plus height 2. So 4 trapezoids from 6 to 15. So we're starting at 6, ending at 15. So we'll do 6 to 8, 8 to 11, 11 to 13, 13 to 15. Okay, subtract your x values there. So 8 minus 6 is 2, 11 minus 8 is 3, 13 minus 11 is 2, 15 minus 13 is 2. Okay. I know right now it feels like, oh, there's only 2 heights involved, so I'm going to pull the 2 heights. But sometimes your region may span across multiple order pairs. If that's the case, make sure that you're only still pulling just 2 heights per interval. So basically, wherever the vertical bars are pointing, those are the y values you're going to choose. Okay, so don't add up a bunch of heights. If you see a bunch of heights, you're only going to associate 2 heights per region. Okay, so let's see. First trapezoid, 1/2 width. My width is 2. Height 1 plus height 2, so 7 plus 3. 1/2 width. Height 1 plus height 2. 1/2 width. Height 1 plus height 2. 1/2 width. Height 1 plus. Okay, next up, use limit definition of area. So this is the formula I'm going to give you. We're going to go ahead and write that down there. But we can start off by finding width, right? So width is b minus a over n. We're not going to have a number for n. We're going to leave n alone. So 1 minus -1 over n. So my width is 2 over n. Next up, let's find our width component. Let me rename this f here. So f of a plus, or left endpoint plus width times I. So my left endpoint is -1. So -1 plus 2 over n I. Okay, this is still not ready for us to multiply with the width. We ought to get this out of function notation. So let's spend the time to do the open parentheses so that we know where this argument is going to go. Okay, we write with the x is removed, so that is where my new argument is going to go. We have our height component, we have our width component. Set that up using my area definition. Okay, spend the time to FOIL this out. Then I can distribute the -2 through. Now I can merge the 3 and 2 together. So I don't want to do 3 minus 2, and then this order of operation tells us multiplication has to be taken care of first before any addition and subtraction. So now I can multiply or add, combine the 3 and 2. Okay, now we've taken care of the height, but don't forget there's still that width component that we haven't done anything yet. Now I'll distribute that 2 over n through. Okay, we know that summation is going to impact each of our terms, so we'll put a summation in front of each of our terms there. One. We know that there is a rule that is going to apply for each of these summations. We can pull the number and the ends out, and then whatever is left over is going to be the rule that we're going to try to find and use. So Right? You look at your rules on page 34 and those. See what we're going to use to replace. So summation 1 gets replaced with n. Summation I gets replaced with n times n plus 1 over 2. Summation I squared gets replaced with n times n plus 1, 2n plus 1 over 6. Okay, so that's the result of summation 1. Here's the result of summation I. And here's the result of summation I squared. So just multiply it to n over n. We know that is going to just be 2 over 1. This one, 16n squared plus 16n. I left out the 16n because I knew that that degree was not high enough to impact my denominator or my numerator. So my highest degree is 2. So anything with a degree 1 is going to be just going to be washed away. So 16 over 2 is 8. And here, last term, if I distribute everything through, but I could do that, but I think the shortcut is just take the first term in each section, multiply that out, and that will give you what we need. The highest degree with the coefficient associated with it. So 16 times n times n times 2n is 32n cubed. There are more terms, but their terms, although the terms will have a lower n degree, which is not going to impact us because we already have the highest degree with the coefficients. So 32 over 6 is what we need. So every fraction will have its own numeric number or fraction, and then we're going to add those, subtract those numbers together to get our exact area.
So is that where you're looking for the exact area?
We're looking for the exact area.
Will that ever be like a place where it's like decimal, or not decimal, but like time involved or something?
No.
Or-
Yeah, it'll be a, yeah, you can use your calculator to just get an exact fractional value. Yeah.
Why are you subtracting 32 over 6?
The reason why is because that's what the rule says here. So I have a minus sign, so I'm just keeping track of that minus sign all the way through until the end.
And where did that minus sign come from again?
Right, that minus sign came from earlier when we FOILed everything out and distributed everything through. It just so happened that the -2 times, yeah, that -2 is causing one of the terms to eventually stay negative.
Trigonometry.
Trigonometric rules? Yeah. I think that's coming up next. Let's see if I can put it.
In the beginning of the problem, how'd you get from step 3 to step 4?
Oh, from here to here?
Yes.
Right. So what I did was, well, I first knew that I can't do the 3 minus 2, right? This is not ready. So I have to take this -2 here and distribute it through to undo my parentheses. Once the parentheses are completed, basically the multiplication portion of the problem, then I can worry about adding and subtracting with that 3. So 2 times 1, -2 times 4 over ni, -2 times 4 over n squared I squared.
Would there be any questions about like we did the first thing, the boxes were like lower and over?
No. Okay. Yeah, you'll see a left. Yeah, it'll the only approximation that you're gonna have to deal with are problems like this, where it's a like this left, right, middle, or table of values and Riemann sums. If you guys are in first period, I have an additional worksheet there. So there's a question about trig. I did not put a trig one on this worksheet, so you can. I call this worksheet 4. I sent it out in the text remind yesterday.
Big question. Do you go for worksheet 3? Do you go for number 7?
Yeah, let's see. Yeah, I'll come back to worksheets. Yeah, I'll come back to worksheet 3. But if you want to answer the question about trig here. So this is number 3 on the new worksheet here. Question was, how do we handle these trig integrals? So first is we want to make sure that we can write out our trig derivative rules. So remember first semester trig derivative rules. So you remember 3 columns. So you want to create your 6 trig derivative rules from scratch, right? So everybody okay with these rules? Okay, so derivative rules, we read from left to right, but integral rules, we read from right to left because we're going backwards this semester. We're going back from our derivative rules. So it says integral of 5 secant tangent. We want to find secant tangent on the right column here. Do you see secant tangent show up on the right side of any of these rules? Yeah, right here. Yep, this one, right? So what do you think the antiderivative of secant tangent will be?
Secant.
Yeah, so that's what this is. The 5 will stay, but I'll have 5 secant x. Next up, cosine. Do you see cosine on the right side of any of these rules? Yeah. What's the integral? What do you think the antiderivative of cosine will be?
Sine.
Positive sign.
So the
Yeah.
negative sign doesn't matter.
Huh?
The negative sign doesn't matter. Negative sign.
Well, basically, this negative is going to have to carry over into the answer because there's no change in sign within this rule, so there'll be negative sign or minus sine x. All right. Do we see cosecant squared show up on the right side? Yeah. What do you think the antiderivative of positive cosine squared will be? Well, the negative has to go somewhere, right? So negative is going to got to bring that negative over. It becomes negative cotangent. Okay. And finally, sine. Do you see sine show up on the right side? Okay. What's the antiderivative of sine?
Negative. Negative.
Negative. Yeah, negative minus 6. And then plus c.
Unnecessary.
Yeah.
There's gonna be that like unequated stuff just like that.
Mm-hmm. Yeah, but I would write down the 6 derivative rules at the top and then just know how to use it. You're using it from right to left.
Basically, if you have the derivative rule numbers, you can basically go off that.
Exactly right. There's no need to rememorize these 12 rules, these additional 6 rules, because you're just working off the same 6, just in a different order. Okay, let's go back to worksheet 3.
Just for my answer, I
Mhm.
got minus 2x to the power 1/2. But I think on the entropy, it wasn't 1/2.
Oh, okay. Let me see. Okay, let's work through it. See if I made a mistake here. So number 7,
Yes.
we'll take the antiderivative. And as I do this, I'm going to clean up my expressions. I know that to do power rule, my variable has to be up top and it has to be converted to rational exponents. So this one, cube root of x turns into what? Yeah, so first is x to the 1/3, and we want to push that x up to the top. So 4x to the square root of x becomes 3x squared. Doesn't need any adjustments. What's the last term going to be? Yeah, so the 3 can stay, but the x needs to come up. Okay, so we're just moving things around so that we're able to produce a starting point that power rule can take. Because if it's not in these right places, then if we try to do power rule, add 1 to the exponent divide, it's not going to come out correctly. So
Why do we dx over?
anytime we take the antiderivative, we just have those notations. That's just notation to indicate I'm about to take the antiderivative.
So it'll always be dx again. Represent.
Yeah, this just indicates that we're taking the antiderivative with respect to x. So this is the variable that we're working with. Okay, so now we can do power rule, right? So add 1 to the exponent. X to the negative 1/3 becomes x to the
2/3 over 2.
Mhm. Okay. X to the
X to 3 halves.
x to the yes.
Other 3 halves.
Right? X to the
Yeah.
Mhm. Finally x to the
-3.
negative 3 plus c. Okay, clean up. Dividing by a fraction is the same thing as multiplying by the reciprocal. So 4 times 3 halves is 12 over 2, which is 6, right? So dividing by 3 halves, same thing as multiplying by 2/3 here. I can knock the 3's out, 3 and 3, so x cubed. Negative 1/3 times, or the 3's in the denominator can multiply. I have 2 negatives there, become positive, so 1/9 x to the negative 3. But I'm gonna drag that x down to the denominator so I can present my answer with a positive exponent. So 1 over 9 x cubed plus c. Was that what you got?
Yes.
Okay.
That is, yeah.
Okay. For power rule, there's another power rule for number 8. Let me shift over to this other worksheet. I think this one is a good one for us to try here. Why don't we do number 2 on the worksheet 4 that you just picked up? Oh, and then I have worksheet 4 here. If you wanna... Okay, good. Okay, so we talked about how there is no quotient rule for antiderivatives. We're going to split up into individual fractions and then clean them up and then just treat them like 3 problems rather than one extended problem that's hard to work with. So let's start off by splitting them up into individual fractions. And I'm going to rewrite these radicals as rational exponents. So first, I just converted the cube root of x to x to the 1/3, converted the root x to be x to the 1/2, and I'm going to start splitting them up into individual fractions. That way, it just feels like, oh, okay, I'm just handling 3 smaller problems rather than one messier one. Okay, everybody good up to that third line? Okay, next up. We are having to merge the x's, right? We can't do power rule if the x is in the denominator, so we have to move it up. And what's one way to combine the x's together? Subtract exponents, right? So 1 minus 1/2, whatever that result is, will be up here. What happens to the 4?
Stays.
Stays. Okay, stays. Just the x comes up. 1/3 minus 1/2, and then 5 minus 1/2. So we think of this as 2 over 2 minus 1 over 2. You can think of this as 2 over 6 minus 3 over 6. Think of this as 10 over 2 minus 1 over 2. Okay, so 2 over 2 minus 1 over 2 is 1 over 2. 2 over 6 minus 3 over 6 is negative 1 over 6. And then 10 over 2 minus 1 over 2 is 9 over 2.
How'd you get 2 over 6 again?
1/3 and 1/2, they both share a denominator of 6. So if I balance my fractions here, 3 times 2 is 6, 1 times 2 is 2. Now, I feel like sometimes in the past, I've seen some students, they feel like, oh, I've done so much work up to this point, this must be the answer, and they would just leave this answer plus C, but we haven't done anything calculus, right? We've just gotten to the starting line. We haven't done the calculus, the power rule yet. So the whole purpose of all that exercise is to get these terms ready so that power rule can be applied, because power rule has certain restrictions, right? No denominator, no radicals, no parentheses. But now that we're at the starting line, we could do power rule. So now we can do the adding 1 and dividing by that new exponent. Okay, any questions up to this point? Okay, so the 5/4 is going to stay out in front. X to the 1/2 becomes what? X to the,
-1.
remember we,
3 over 2.
yeah, so add 1 to the exponent. So 3/2 over 3/2. Okay, negative 1/6 becomes 5 over 6 divided by 5 over 6.
How come you're adding?
Because we're doing power rule for antiderivatives. We add 1 to the exponent divided by the.
Oh, you're power for
Right. Power rule for antiderivatives. 9/2 becomes, yeah, 9 over 2 plus 2 over 2 is 11 over 2. So 11 over 2 over 11 over 2. Okay, I want to talk this through first before, so that we're clear as to where these numbers are coming from. So the 3/2 is showing up here, 5/6, 11/2. Which part? Okay, so here we are adding 1 to the exponents. So let me work out that step. So right, 1/2 plus 2 over 2 is 3 over 2. Negative 1/6 plus 1 is 5 over 6, because that's 6 plus 6 over 6. And then 9 over 2 plus 2 over 2 is 11 over 2. Okay, good. Any other questions up to this stage? Are we good here? So we want to combine these fractions here. There's a complex fraction here. So dividing by 3/2 is the same thing as multiplying by 2/3. Okay. Dividing by 5/6 is the same thing as multiplying by 6 over 5. And then divided by 11 over 2 is the same thing as multiplying by 2 over 11. So the nice thing is that once you get into multiplication, then it's at the same level as your fraction above. And then you just multiply across, right? 10 over 12, 6 over 10, 2 over 44. And then if you want to reduce, you can. The calculator can do it for you as well. Okay, going back to worksheet 3. Let's try 9 and 10. Everybody good here? Okay, 9 says find the general expression. So we'll just take the antiderivative twice. First time through, we'll get a plus c. Second time through, we'll get a plus c sub 1x plus c sub 2, or plus c sub 1x plus k, or plus c x plus k. Okay, so we're just setting this up to get us ready to take the antiderivative. We want to give that notation to indicate what action we're about to take, and then we can take our action. 2x cubed becomes 2x fourth over 4. 3x squared becomes 3x cubed over 3. X becomes x squared over 2. 1 becomes x, and then a plus c. So this takes us to the halfway point. Now we can do the antiderivative of this expression. So let me show that step here. The integral of 1/2 x to the 4th plus x cubed plus 1/2 x squared minus x plus c dx. Okay, so this is my halfway point here. Just clean that up. I've set myself ready to get ready to take the antiderivative again. This will take me from the f prime level up to f of x level. So we go through power rule. X to the 4th becomes x to the 5th over 5. X cubed becomes x to the 4th over 4. X squared becomes x cubed over 3. X becomes x squared over 2. The c becomes cx, and then it will produce its own constant c sub 2 or k.
Read number 10 too, right?
Yeah, number 10. Okay, here's number 10. It says find a specific expression, but we're at the second derivative level. So we'll take the antiderivative, we'll get a plus c to show up. This order pair will help us solve for that c at that prime level. And then once we get that c taken care of, then we'll take the antiderivative again. Another plus c sub 2 or plus k will show up, and we'll use the second order pair at the function level to solve for that constant. Okay, so I'm setting myself up here to get the first antiderivative up to the f prime level. Go through power rule.
Okay, so now that we're at the F prime level, that plus C shows up. We have an order pair at that level that we can use. So we'll insert -1 in for X and 9 in for the F prime variable. The 4's cancel out. I subtract 9. Everything goes away. My C is just 0. So because my C is 0, I can just completely drop that constant out. Looks like I can just ignore it now. If this was another number, I'll have to replace that with another number, but 0 can just go away. I'm going to rewrite my F prime, and I'm going to just completely drop the 0 because it's not going to. So my F prime updated is just 4x cubed plus 9x squared minus 4x. That plus 0 is not going to matter, so it just goes away. Okay, so we're halfway there. Antiderivative of F prime. So if I want to get to the F of X level, I'll take the antiderivative of my expression. Okay, power rule again. Plus C sub 2 or plus K. Do some cleanup before I plug in my order pair there. Okay, plug 1 in for X, 3 in for Y, solve for C sub 2, and then I can then produce my specific expression. Four minus 2 is 2. C sub 2 equals 1. And I can rewrite my function with my C sub 2 replaced.
Wait, how'd you get the?
I just combine these terms here. 1 plus 3 is 4. 4 minus 2 is 2. So 3 equals 2 plus C. And I subtracted 2 to the other side.
Oh.
3 minus 2 is 1. Here's my answer here.
Okay. So you just skip the regular X instead of 0.
Yeah, I skipped that the constant at the F prime level because it's 0, so I didn't need to keep track of that. But
So the question we just like trainers.
I'll spoil everything else. Okay. Spoil everything else, get everything nice and ready, then power. Yeah. So there you go. Battery. Guys, eventually I'm gonna need all your book bags up in the front and then your phones up against the wall.
I swear I'm gonna flip the trapezoid. I just worried I'm gonna forget the calculus.
What do you think it is right now?
W over 2 with brackets and it's H1 plus H2. Okay.
Yeah, it's gonna be light.
And I can get the trigger. Domino effects.
I was up till 2 a.m. because we had a deck before everything else. Every night.
Midnight.
You know what I've been saying? It's a favorite project, like it's really.
That was the previous project on this.
No class. Yeah, no class grading. You get to use your calculators.
Maybe. I'm not finding. I'm not gonna do this. I'm not gonna do this. I'm gonna be able to observe that.
Yeah, you're right.
Did you?
It's like summation ones, I'm sure.
I switched to.
Thank you.
Guys, if you need scratch sheet, use the formula sheets.